Experiment number 7. Specific gravity of soil. First part objectives: to determine the specific gravity of soil solids using a pyknometer method, and to understand its importance in evaluating fundamental soil properties used in geotechnical engineering. Intended learning outcomes (ILS). After completing this laboratory experiment, students should be able to 1. Define specific gravity of soil solids and explain its engineering significance. 2. Perform pyknometer test in accordance with STEM 354 to obtain accurate measurements. 3. Calculate specific gravity Gs of soil solids using measured mass and temperature depth. 4. Apply the concept of specific gravity in the analysis of void ratio, degree of saturation, and weight-volume relationships of soils.
Discussions. The determination of specific gravity of soil solids using measured soil in the pyknometer method provides a fundamental parameter required in soil mechanics analysis. By comparing the unit weight of soil solids to that of water at a standard temperature, the test isolates the density characteristics of the solid fraction of the soils. Accurate measurement of specific gravity is essential because it directly influences the computation of key engineering properties such as void ration, degree of saturation, and weight-volume relationships. The controlled procedure, including oven drying, removal of entrapped air through boiling, and temperature correction, ensure reliable results that can be confidently applied in geotechnical design and soil classification. Resources: drying oven, thermostatically controlled oven, temperature between 110 plus degrees Celsius, pyknometer or 500 ml volumetric flask with stopper having pipe hole, thermometer graduates in 0.5 division scale, balance sensitive to 0.1 G, distilled water, evaporation dish, spatula, spoon, funnel. 5. Procedure. First, determine and record the weight of the pyknometer filled with water, W sub A to the calibration mark. Second, prepare the dry sample per recommended weight indicated in Table 1 below. Determine and record the weight of the oven-dried soil, W sub 0. Third, add distilled water to fill about half to 3/4 of the pyknometer. Soak the sample for 10 minutes. Fourth, boil the pyknometer to release the entrapped air in hot water but allow the to cool to room temperature of the water once it equalizes with room temperature. Fifth, record the weight of the pyknometer filled with water and soil, W sub B. For the data and results. This table shows the data and results from our laboratory experiment for determining the specific gravity of soil solids using the pyknometer method. We prepared for soil samples and recorded the measured final temperature of the mixture because temperature affects the density of water. That is why we used a temperature coefficient, represented by K, for correction. The oven-dried weight of the soil sample, or W, was maintained at 200 grams for all trials. We also measured the weight of the pyknometer filled with water, represented by W, and the weight of the pyknometer with oven-dried soil and water, represented by W. Using these values, we calculated the specific gravity of soil solids, or Gs, through the formula. For sample 1, substituting the values into the equation gives G S equals 206.50775, 200 0.998, equals to 0.661. The computed specific gravity values for the 4 samples ranged from approximately to 0.59 to 0.79. These results indicate the relative density of the soil solids compared to water and help in identifying the type and properties of the soil used in the experiment. For the conclusion, the experiment on the determination of the specific gravity of soil solids using the pyknometer method was successfully conducted. The computed values of specific gravity ranged from 0.57 and to 0.74, which are within the normal range for most mineral soils. The results shown that the soil particles are denser than water and contain typical inorganic materials commonly found in geotechnical engineering soils.